Hey everyone! In this video, we're going to be taking a look at how to work with parallelograms in the coordinate plane. Now the first thing, just remember when we're working in the coordinate plane, that allows us to bridge the gap between geometry and algebra. That means that we can use a lot of our algebraic formulas, such as distance and midpoint and slope, as we work with our geometric shapes. So what I want to do is just go through two examples using some of these formulas, using some of our algebra with parallelograms. So the first example, find the coordinates of the intersection of the diagonals of parallelogram STUV with the vertices -2, 3, 1, 5, 6, 3, and 3, 1. So let's start by graphing this parallelogram to see what we're working with. So our first vertex is at -2, 3. So this is S. T is 1, 5. 1, 2, 3, 4, 5. 6, 3 for U. 1, 2, 3, 4, 5, 6, and 3. And lastly, the point V is at 3, 1. So here's our vertices, and I'll connect these together with some segments to form our parallelogram. All right, so here's our parallelogram. It's nice to graph this right away and just take a look to make sure we have everything in the correct spots. With a parallelogram, it's easy to tell if you made a mistake because we know, definition of parallelogram, the opposite sides need to be parallel, which, taking a look, everything looks okay here. Now I want to find the intersection of the diagonals. So let me draw in the two diagonals. So from T to V and from S to U. So we want to find out where these intersect. Now there is a property of parallelograms that says that the diagonals bisect each other, which means that they cut each other in half. So let's label this point here, let's just say that this is A. So from T to A is the same distance as from A to V, because the diagonal SU bisects or cuts in half the other diagonal TV. And the same thing going the other direction. So from A to S is the same distance as from A to U. Again, it's getting bisected. Because these diagonals are getting bisected, that means that this point that I labeled as A, that intersection, that has to be the midpoint of either of these diagonals. It's actually the midpoint of both of them. So if I want to quickly find this intersection, what I can do is I can just find the midpoint of one of the diagonals. And I can use either one. So why don't we use TV? So we're going to use these 2 points. So the midpoint, remember, it's the average of the x values and the average of the y values. So we'll add our x's together and divide by 2. We'll add the y's together and divide by 2. So my 2 x values, we have 1 and 3. The 2 y values, we have 5 and 1. So 1 and 3 together, we get 4 divided by 2 is 2. 5 and 1 is 6 divided by 2, and we get 3. So this point A, this should be the point 2, 3. So if we count that out, 1, 2, 1, 2, 3, and that looks like we are correct. So the midpoint of one of those diagonals is the intersection of both the diagonals in a parallelogram. So that's just one example and how we can use an algebraic formula to help us find out one of these pieces about our parallelogram. Now let's take a look at one more example, and this one's a little bit different. So in this example, I'm given 3 of the 4 vertices of my parallelogram. I need to find the 4th one. Let's start by just graphing the 3 that we are given. So we have 2, 4. So this is point A. 5, 2, 1, 2, 3, 4, 5, and 2. And lastly, the point C is 3, -1. All right, so now I will connect these together. So we have A, B, and C. And now I need to find where this fourth vertex, point D, is going to be located. Now, I did draw in two of the segments already, so we can guess as to see where this fourth vertex is going to be. Now, a couple reasons, in a couple ways I know that it's going to be over in this general area. The first is the order of the vertices in the naming of my parallelogram is important. So A, B, C, D, this tells me the consecutive order of these vertices. So as I make my way around the parallelogram, they have to go in the order A to B to C. If I didn't draw in these segments, I could visualize a parallelogram that has the fourth vertex over here somewhere. But if I drew that in, so let's say, just kind of eyeballing, maybe it's right here and this is point D, and I connect that together to form the parallelogram, these vertices wouldn't go in the correct order. It'd go A to D, B, C, back to A, which doesn't match up with the naming we have. So, based on the naming here, I know that A and B are consecutive, meaning I can connect them together with a segment, B and C. So just knowing that, drawing in those segments, I can tell that my vertex, this last one, is going to be over in this region here. Now, how can I find that? Well, we can use our slopes. We know that the opposite sides of parallelograms have to be parallel. So why don't we just take a look at the slope from A to B. So from A to B, I need to go down to over 3. So this segment has a slope of -2/3. That means the opposite side of our parallelogram also has to have a slope of -2/3. So if I just use that slope and I go backwards, if I go to the left 3 spots and I go up 2 spots, that location should be my fourth vertex. So I went down 2 over 3, and then on the other side of the parallelogram, I just need to repeat that, and then this should be the point D. So let me draw in the last 2 segments, and we can visualize this and see if this did work. So if I connect A to D, and then D to C, it does end up looking like we have a parallelogram. We know that DC and AB are parallel just because we counted it out. And let's just verify with our other 2 segments. For segment BC, we have to go up 1, 2, 3 over 2. So this has a slope of 3/2. And then lastly, over here, AD, 1, 2, 3 over 2. So we're going up 3 to the right 2. So this segment also has a slope of 3/2. So our opposite sides have the same slope, meaning they're parallel. So that means our fourth vertex, so point D, is at the point 0, 1. So there's 2 examples. One of them, we use the midpoint formula to help us find the intersection of the diagonals. And in the second example, we're using these slopes to help us find the last vertex. But again, overall, when we're working in the coordinate plane, it's important to remember that that opens up all these algebra tools that we can use to help us solve problems.